3D transforms are an extension of 2D transforms. They move an element out of the usual X and Y plane by introducing a Z-axis where elements can be translated, rotated, and scaled within a 3D perspective we establish on the page. A 3D transform will run smoothly when applied to any visible DOM element because they're hardware accelerated and they're simple to implement. Let's find out how. A 3D transformed element is still two-dimensional. It just no longer lies in the usual plane, and it's able to be translated along the z-axis and rotated around the x or y-axis. We can also transform an element using a combination of translate and rotate. So let's take a look at a few examples. In our HTML file here, we still have our wrap div element, and nested inside, I've added two divs, one with the class side A, and the other has a class of side B. And I've linked them to a style sheet with some base styles. For example, I've added a background image to both divs, and I've positioned wrap to relative, and I've added some box shadows and things like that. So this is what it's looking like in the browser. They're stacked on top of each other. The A side is on top and the side B div at the bottom. So what we want to do is first bring this side B div behind side A, and we can easily do this by adding a position of absolute to both divs nested inside of wrap. So we'll first select wrap, followed by div, give it a position property with a value of absolute. And I will go ahead and add a higher z index to our side A div, just so we can see it on top. So we'll give it a z index of 100. And there we go. So we'll see the side div area again in just a few when we rotate this containing wrap element in 3D space. So before we can transform an element in 3D, we'll need to first establish a 3D perspective on the page. Otherwise, it will still appear as a 2D transformation. To configure this 3D space, we'll need to use the perspective property. The perspective value we define gets applied to the direct child elements only. So we will go ahead and apply a perspective to the body of the page. So we will type WebKit perspective, and we will give it a value of 800 pixels. So now we're telling the body that its direct children are ready to move around in 3D space. When we define our perspective, its value is the distance from the drawing surface to the assumed position of the viewer's eye. It can be compared to the field viewing angle of a camera. The smaller the perspective value is, the deeper the perspective is, and the larger the value, the shallower it becomes. So the 800 value I chose here gives us a reasonable perspective. Anything from 800 pixels to 1000 pixels is pretty common, so we'll just keep ours at 800 pixels. So we added our perspective, and in the browser, we don't really see any visual changes yet on the page. Well, that's because the perspective value alone will not cause any changes to the appearance of the body element. The only thing we're doing here is determining how the direct children of body will be rendered. So now we can work in this 3D space we just created. And we can use many of the same transform functions we covered in the previous video, but this time we'll see how they behave differently in the 3D space, and how we can also control the z-axis with the z and 3D functions. So we want to see our 3D transforms happen on the wrap element when we hover over it. So let's create a new rule using the hover pseudo class on wrap. Then we'll add the WebKit transform property. And we also want a smooth transition with our transforms. So let's quickly add one. We'll go ahead and add it to wrap. And we want to transition the transform property. So again, WebKit transform so that all our transforms are transitioned. And we'll give it a 1 second duration, and ease in will be our transition timing function. So let's take a look at the rotate function first. So now, besides being able to rotate elements clockwise or counterclockwise, as we would with 2D rotations, we can also rotate them in this 3D space we just created. So in our wrap hover rule here, we will type rotate, and we will look at X first, and we will specify a value of 45 degrees. So now, besides just being able to rotate the element clockwise or counterclockwise, as we would with 2D rotations, we can also rotate them in this 3D space. So we'll save this. We'll take a look at it in the browser. And when we hover over our wrap element, we can see how it rotates it back at a 45-degree angle on the x-axis. So we really see this 3D effect here as the bottom of the element moves towards the viewport and tilts it back. And if the rotate x argument is a negative value, it then rotates in the opposite direction. So this is where we can really test these different perspectives. For example, back in our body rule, I'll change the perspective value to 400 pixels. So now when we refresh and hover over the element, we see these shifts in perspectives happening. Because the value is lower, we get that deeper perspective. But if we change it to something higher, like 1200 pixels, the perspective then becomes shallow. And we can also see this with rotate Y. And I'll go ahead and just change this to 300 pixels. And now we see this deep perspective from the side. But we'll again change our perspective back to 800 pixels. So there's a new value, rotate Z, which rotates the element on the Z-axis. So it's very similar to how elements rotate clockwise and counterclockwise in 2D space. For example, a rotate Z value of 65 degrees rotates our element clockwise 65 degrees. And if it's a negative value, it then rotates it counterclockwise. We can perform a 3D rotation using the X, Y, and Z axis at once in one argument. For example, the rotate 3D function accepts 4 values. The first 3 values set the direction, and the 4th value sets the rotation angle. So X, Y, and Z are always number values, usually 0 or 1, and we'll see why in just a bit. And the 4th value is the angle that makes the rotation happen. So with this rotation 3D method in place, the browser rotates the element around a vector in 3D space. So the X, Y, and Z values specify the unit vector to rotate around. If any of these X, Y, and Z values are set to 1, the element will rotate by the degrees we specified in the 4th value. If any are set to 0, then the one set to 0 will not rotate. So for example, this value right here will rotate our element 65 degrees forward on the x-axis and 65 degrees clockwise in the y-axis. And it will provide no rotation on the x-axis because we set the value to 0. So we'll go ahead and save this, and we'll see what that looks like. Pretty cool. And if we change our value to, say, 1, 0, 1, now only the x and z-axis will rotate those 65 degrees.